Hi everyone, Dr. Rashid here. In this video, I will explain you vitamin B2 in detail. So vitamin B2, it is also known as riboflavin. So let's see what are the coenzyme forms of riboflavin. There are two coenzyme forms for riboflavin. One is FMN and second one is FAD. FMN stands for flavin mononucleotide and FAD means flavin adenine dinucleotide. And this FMN and FAD have a role in oxidation reduction reaction. Both FMN and FAD act as a component of electron transport chain. So let's see where it is located. So FMN is present in the complex 1 of the electron transport chain as a part of NADH dehydrogenase, whereas FAD is present in the complex 2 of the electron transport chain as a part of succinate dehydrogenase. So NADH dehydrogenase enzyme contain FMN and succinate dehydrogenase enzyme contain FAD. So let's see what are the other enzymes which require FAD. So other FAD dependent enzymes. So just remember the multi-enzyme complex as explained in the timing. There are three multi-enzyme complex. One is pyruvate dehydrogenase enzyme complex which catalyzes oxidative decarboxylation of pyruvate into acetyl-CoA. The second multi-enzyme complex is alpha ketoglutarate dehydrogenase. They catalyzes oxidative decarboxylation of alpha ketoglutarate into succinyl-CoA. And the third enzyme complex is multi-enzyme complex is branch chain ketoacid dehydrogenase. They are concerned with the metabolism of branch chain amino acid like valine, leucine and isoleucine. And all these multi-enzyme complex contain multiple enzymes and multiple coenzymes. So what are the coenzyme molecule? One is B1, B2, B2 is riboflavin, and B3 that is niacin, and vitamin B5 that is pantothenic acid in the form of coenzyme A. So B1 is present in the form of thiamine pyrophosphate, B2 is present in the form of FAD, B3 is present in the form of NAD, and B5 is present in the form of coenzyme A. And all these vitamins are present in all these three multi-enzyme complexes. So that's all regarding biochemical functions of riboflavin. So let's see the deficiency manifestation of riboflavin. So riboflavin deficiency produces, one is ophthalmic manifestation, second one manifestation in mouth. So let's see the ophthalmic manifestation of riboflavin deficiency. See, this is the cornea. So around this cornea, the patient will develop congestion, circumcorneal congestion. So this manifestation is known as circumcorneal congestion. So circumcorneal congestion is one of the manifestations seen in riboflavin deficiency. And the clinical picture is almost similar to conjunctivitis. So let's see the oral manifestation. So the patient may develop erythematous, edematous tongue. So the tongue may be erythematous and edematous, and this feature is known as glossitis. So glossitis means erythematous, edematous tongue. And the lip may also develop reddish discoloration, and that feature is known as cheilosis. So reddish discoloration of lip is known as cheilosis, and it is also one of the manifestations seen in vitamin B2 deficiency. And there may be erythematous lesion near the angle of the mouth. So this is the angle of the mouth, and this region also may have erythematous lesion, and which is known as angular stomatitis. So that is also another manifestation of vitamin B2 deficiency. So vitamin B2 deficiency produces glossitis, that is erythematous edematous tongue, and cheilosis, that is the reddish discoloration of the lips, and the angular stomatitis, that is the erythematous lesion affecting the angles of the mouth. So glossitis, cheilosis and angular stomatitis, these are the manifestations seen in oral cavity. And circumcorneal vascularization, that is the manifestation seen in eye. So these are the deficiency manifestations of riboflavin. So that's all regarding vitamin B2. So let's see some questions. So the first question is, what are the biological active forms of riboflavin? There are two biological active forms of riboflavin. One is FMN and FAD. So FMN and FAD are the biological active form of riboflavin. So what are the enzymes which contain FMN? That is complex 1 of electron transport chain, that is NADH dehydrogenase enzyme. And complex 2 of the electron transport chain contain an enzyme succinate dehydrogenase, and this succinate dehydrogenase contain FAD as the coenzyme molecule. And FAD is also the coenzyme molecules for multi-enzyme complexes. So the second question is, name 4 enzymes where FAD act as a coenzymes. So in all this reaction, FAD accept this electron or proton, and this FAD is converted into FADH2. So the first enzyme is succinate dehydrogenase enzyme, and the second one is pyruvate dehydrogenase enzyme complex, and the third one is alpha ketoglutarate dehydrogenase enzyme complex, and the last enzyme complex is branch chain amino acid dehydrogenase enzyme. So these are the enzymes which require FAD as the coenzyme molecule. So the third question, what is the disease produced by riboflavin deficiency? So riboflavin deficiency produces ophthalmic manifestation as circumcorneal vascularization, and also produces manifestation in mouth like glossitis, cheilosis and angular stomatitis. So that's all regarding riboflavin. Thank you.